Hi, today we're going to be looking at Lesson 7.1, Equivalent Trigonometric Functions. The goal of today's lesson is to identify equivalent trigonometric relationships. This will allow you to use angles that are different than just the special angles that we've been looking at over the past unit. Okay, so take a look at this graph. And I know the scale's in degrees, but think of it as radians, please, in terms of pi, and come up with a few different equations for that graph. Okay, so please pause the video, and I'd like to see six equations for that, even though there are infinite number, but please come up with 6 equations for this function. Okay, so there are a few obvious ones here. So one could be y equals negative sine theta. Okay, so that's the negative out front is a vertical or reflection in the theta axis, so it's a vertical reflection. Then if we stick to the sine function, we could say it's also y equals sine theta plus pi. Okay, so meaning that it's been shifted to the left, a phase shift to the left of pi. So that means that this would be the beginning of the curve here. So it's been shifted over this way by pi. We could also say then that it is a sine of theta minus pi, meaning that it's been shifted to the right by pi, which would indicate that this would be the beginning of the curve here. Okay, so there's 3 if we think of it as a sine function. Then if we look at it as a cosine function, what would happen here? So we got y equals, okay, so just for example, cosine of theta plus pi by 2. Okay, so that's a phase shift to the left of pi by 2. So cosine would normally start at a value of 1, but it's been shifted to the left pi by 2, so that's where it begins there. If we continue with this as a cosine curve, we could say this is cosine of theta minus 3 pi by 2. So this is the maximum here, and this is 3 pi by 2 away from the vertex, or sorry, the y-axis. So it can be shifted to the right 3 pi by 2. And we could also see it as y equals negative cosine theta minus pi by 2. So it's been reflected in the theta axis and shifted to the right pi by 2, meaning that this would be the beginning of a typical cosine curve where it would start at 1 when theta is 0. So it's been reflected and then shifted to the right by pi by 2. Okay, so some of you may have had some of these, some of you would have had perhaps equations that were different than these. As long as the phase shifts and the reflections work out the same, then there's no problem whatsoever. Okay, so there are of course many different possible equations that represent the same trigonometric function. Okay, so now let's continue looking at these equivalent trigonometric functions. Suppose we choose some value of theta. Suppose we got some theta value here. Don't know what that is, but we see that if we go directly vertical until it hits the cosine curve, it has a certain value of y. Now if I extend that over to touch the same y value on the opposite side of the y-axis, we'll notice that we have the same theta value, but in this case it's negative. Okay, same kind of thing could happen. Suppose we take some value over here, doesn't really matter where. Here's our theta, and we see that it hits the cosine curve there, which has some specific value of y. And then if we extend that line till with the same value of y, it hits the cosine curve here, which gives us a negative theta. Because if theta here is negative, then a negative theta would be a negative negative, which means a positive theta here, would be the same distance from the y-axis. Okay, thus shows that cosine is an even function because it is symmetric about the y-axis. So how can we reflect the graph of f of theta equals cos theta to produce the same graph? Well, what we'd have to do is cos of negative theta, which is cos theta. And that negative indicates, in terms of transformations, a reflection in the, in the y-axis. Okay, so we can say that cos of negative theta, reflects cos theta in the y-axis. Reflecting a graph that is symmetric about the y-axis in the y-axis produces a graph that is equivalent to the original. And we can also look at it in another way. Suppose we have a Cartesian plane here. And we have some angle theta, some positive angle theta in center position. We see that angle theta rotates counterclockwise from the positive x-axis, and cosine is positive here because that's in the quadrant where all trigonometric functions are positive. And the only other place where cosine is positive is in the fourth quadrant, where only cos is positive according to the cast rule, and we see that this rotation is negative theta because it rotates in a clockwise manner. Therefore, cosine of negative theta equals the cosine of theta, just like we saw up here. Let's move along to sine function now.